So finishing up that last thought, the blood perfusion or movement through the capillary beds is regulated to meet the local demands. With the examples there I was giving of, say, the skeletal muscle, you're running to catch a bus, or the capillary beds at the digestive system after you've had a meal, for example. Okay? There's also arteriovenous anastomoses, and these are just additional blood vessels that you would find that would help ensure, that you would find in tissues and associated with capillary beds to help ensure that there's blood flow to a region if there happens to be, say, a blockage. So an anastomosis is an additional kind of redundant blood vessel. Oh, here's a little diagram again showing full perfusion, blood flow through a particular capillary bed, and all of the blood is moving through what are referred to as the true capillaries. Let me go back one slide. So these here are the true capillaries, and then that would be the thoroughfare channel. So there's your thoroughfare channel and the true capillaries, full blood flow through this capillary bed because all of the precapillary sphincters are open. The muscles there are relaxed, the little ring of smooth muscle. So allowing full perfusion of blood, movement of blood through that particular capillary bed. Down here at the bottom, the true capillaries have been cut off because the precapillary sphincters are contracted. Maybe there's a little bit of blood through there or none at all. And then the blood flow through this capillary bed is essentially shunted through the thoroughfare channel. And again, up at the top would be a situation where this particular capillary bed, this particular tissue is requiring plenty of oxygen and nutrients. And then down here, at the bottom, that particular tissue is not requiring very much. So let's move on to the venules. So the venules drain the capillary beds. So notice post-capillary venule. So they are small and thinly walled down here. Actually, I don't even have a picture of a venule, but then down here at the very bottom. And one reason why they're so thin, all the veins, is because the blood pressure has dropped considerably at the capillary beds, and then even further so through the veins, venules and veins. So the venules merge into small veins. They have less elastic and smooth muscle tissue versus their corresponding arteries. And again, that's because of the low blood pressure of the blood moving through these veins. So structurally, they simply don't have to be so thick as the corresponding arteries. The blood pressure, though, is so low that the veins need an additional mechanism to allow the blood to get all the way back to the heart. If there was no additional mechanism, for example, valves, and another mechanism that we'll talk about, the blood pressure alone would be insufficient to ensure adequate blood return back to the heart. So there are valves that are appearing in the veins, just like we saw valves in the lymphatic system, in the lymphatic venules. So here are valves, and then many of the veins are going through the musculature. So when the muscles contract, that squeezes the veins, and imagine squeezing a balloon. In the middle, you'd have the water wanting to move in both directions, right, away from where it's being squeezed. Well, the blood vessels, these veins, when they're squeezed by the contracting muscles, it pushes the blood up in this case, but also down. But the blood flow down is limited, reduced because of the presence of these veins. So as the blood moves through, percolates through, and the muscles contract, the blood is kind of pushed in one direction back towards the heart. Oh, so this mechanism here, besides the valves within the veins, this mechanism here of the contracting muscles is referred to as the skeletal muscle pump that allows or assists the blood in getting pumped back up towards the heart, the skeletal muscular pump. So, circulatory routes. Pulmonary circuit or circulation is from the heart to the lungs and back. Systemic circuit or circulation is from the heart to the whole body, the system, and then back towards the heart. And then, of course, the cardiac circuit or circulation is the blood supply to the musculature of the heart. So here we go. Remember the blood supply, the blood vessels, the coronary arteries and veins that are supplying nutrients and removing wastes from the cardiac musculature. And then we'll talk a little bit about the fetal circulation or the fetal circuit. Here we go. And of course, the lifeline, umbilical cord, via the placenta to the mom's blood supply, cardiovascular system. So, pulmonary circuit or circulation, that is the circuit that is taking oxygen-poor blood from the right side of the heart, carrying it to the lungs for gas exchange at the small little air pockets referred to as alveoli. Alveolus is singular. Gas exchange is occurring there. Carbon dioxide leaves the blood supply, enters into the alveoli, and eventually you exhale it out. Oxygen moves in the opposite direction from the inhaled air, diffuses across the membrane, and gets into the capillaries, into the blood supply. So with the pulmonary circuit, the pulmonary trunk is carrying oxygen-poor blood from the right side of the heart. Oxygen-poor blood enters into the right side, the right atrium, via inferior vena cava, superior vena cava, and then the coronary sinus itself. So the right atrium is receiving oxygen-poor blood. That moves down into the right ventricle, past the right AV valve, the tricuspid valve. Then when the ventricles contract, blood is forced out of the right ventricle, pushing past the pulmonary valve into the pulmonary trunk, then the pulmonary arteries, arterioles, etc., capillary networks surrounding the alveoli. So notice they're color-coded blue, even though they are arteries, because they are carrying oxygen-poor blood. And they are arteries because they're carrying blood away from the heart. Gas exchange in the heart, oxygenated blood is returning via pulmonary veins, and they empty, bringing oxygen-rich blood into the left ventricle. Atrium, dropping into the left ventricle. And when that contracts, right past the mitral valve, bicuspid valve, left AV valve, when the ventricles contract, that oxygen-rich blood then leaves the left ventricle, pushing past the aortic semilunar valves, entering into the aorta, and then the systemic circuit is carrying oxygenated blood to the body. So here we go, pulmonary trunk, pulmonary arteries in blue, lungs, gas exchange, return, pulmonary veins, left atrium. Systemic arteries. Let's go back to this picture real quick. As was covered in the heart chapter, this, just to review, explains why the right side of the heart is less muscular, more thinly walled. The right ventricle is much thinner walled than the left ventricle. Left ventricle is more powerful because the right side of the heart, the right ventricle, only has to pump blood to the lungs, which are basically surrounding the heart, and then back. So it's a simpler, easier circuit to work. The left ventricle has to pump with enough force to get blood everywhere. Head, neck, arms, fingers, torso, legs, toes, with enough force that the blood can actually start to work its way back to the heart. So the left side of the heart, the left ventricle, has to work harder. It's stronger, much more thickly walled. And we covered that in the heart chapter. Systemic arteries now, the ones to know. And this should match your lab study guide. So you have the aortic semilunar valve. We'll start there, so starting in the heart, and we'll go all the way back towards the right atrium. Okay, so the larger principal arteries are what we'll cover. The ascending aorta is the part of the aorta that first comes off of the heart. Ascending because it's going superiorly upwards. Then the aortic arch is where it arches over, and there's 3 big arteries that come off of that. The first one on the right side is called the brachiocephalic trunk. Then number 2 is the left common carotid artery going up to the head. And then the third one here, see a little bit of it, the left subclavian artery, subclavian because it goes below the clavicle, and then that drops towards the shoulder, armpit area, and then down into the arm. So the first 3 arteries off of the aorta. Then the right subclavian, as we see here, branches off of the brachiocephalic trunk, the right subclavian, in addition to the right. Oh, we'll continue with the subclavian, sorry. So the right subclavian. So again, ascending aorta, aortic arch, brachiocephalic trunk, right subclavian artery, right, there's the clavicle, and then right axillary. It transitions to the right axillary artery, relatively short, but remember there's the axilla, the armpit area, and then that drops into the brachium, so right brachial artery, and then towards the elbow, that branches past the elbow there, elbow joint, towards the right radial artery. There's the radius, right radial artery, the radius bone. There's the ulnar bone, and then also there's the right ulnar artery. Those 2, right radial, left ulnar arteries, branch off of the right brachial artery. And we'll end there. There's other arteries that go all the way into the digits that we don't need to know by name. Okay, let's move up into the head. So there's the brachiocephalic trunk, right? And there's the right subclavian, right axillary, etc. Now going up towards the head to serve the head and the brain, you have off of the brachiocephalic trunk, there's a nice big right common carotid artery where you can feel your pulse. Make sure you have one. And then there's the right subclavian. Okay, both of those off the brachiocephalic trunk. And then off of the right common carotid, nice thick one here, it branches. The one that goes deeper into the skull to serve the brain is the internal carotid artery. These are on the right side, so the right internal carotid artery. And then the one that's more superficial, serving the face and the skin, that would be the external carotid artery. And then notice it branches into the facial, ophthalmic, eye, maxillary. Those we don't need to know by name. Again, just what you see up here in the text. Okay, so internal and external carotid arteries. When it comes to quiz, exam time, whatever, if I want an answer for a particular blood vessel, make sure you give me external carotid artery, all right, or right common carotid artery. Make sure you identify if it's an artery or a vein. Continuing into the brain, what's referred to as the cerebral arterial circle, also called the circle of Willis, at the base of the brain, essentially. So again, from the right brachiocephalic trunk, you get the subclavian, right subclavian artery, because we're on the right side here. And notice this little blood vessel, not so little, but it comes in through the transverse foramina of the vertebral bones. That is the vertebral artery, the right one. And then that goes up into the brain. The vertebral artery, both of them, merge into the basilar artery. All right, so brachiocephalic, subclavian, vertebral artery into the skull, merging into one basilar artery, because it's like at the base of the circle of Willis. Then from there, you get the posterior cerebral, So technically now we're in the